Question 1. A compound U melts at 82 degrees Celsius and boils at 113 degrees Celsius. If U was found to be insoluble in water, a mixture of U in water would best be separated by. Now, the very important information here is that U is insoluble in water. So we'll take advantage of that particular physical property. So let's say we have a beaker with water and U in it. U either floats on the water or it settles at the bottom, whichever way it is insoluble in water. Now, the most suitable setup to use to separate U from water is to use a filtration apparatus. Here we'll get a conical flask, a funnel, and a filter paper, and a cotton wool. And then we'll pour the mixture onto our filter paper in the funnel. Now, U, being insoluble in water, would collect as the residue, to be stopped by the filter paper, and is collected as a residue, while the water now will pass through the funnel and is collected in the conical flask as the filtrate. Therefore, the answer to our question here is filtration as the most suitable method for separating U from water. Question 2. A dye is suspected to have contaminated a lollipop. Which of the following is the best method by which the contaminant may be isolated? Now, we're talking about a dye, which is typically a colored pigment. The most suitable method here is the use of chromatography. And one of the most common methods used is paper chromatography, which takes advantage of the difference in the solubility of that pigment or that dye or that contaminant in a particular solvent. So we could get any solvent of choice here, which could be water, or it could be acetone or alcohol. And then we get our paper chromatogram or chromatographic paper. And then all we need to do is just get a pencil line, which should be above the solvent, of course. And then just put a drop of our mixture here. And then watch as the various components separate out. So the answer to this question is paper chromatography, method that is used to separate colored mixtures or dyes, if you like. Question 3. A mixture containing two salts of different solubility can be separated by. Mixture containing two salts of different solubility can be separated by. Now, when we have a mixture of two salts with different solubilities, the first thing that comes to mind here is that their solubilities will differ at different temperatures. So we use a method called crystallization, where we can have this container, a beaker probably, and then we can have a solution of these salts. A solution of these salts, say salt A and salt B. Now, at different temperatures, their solubilities will differ. So we'll first of all heat this solution so that both of them are soluble. Then we allow the solution to begin to cool. Now, during cooling, At specific temperatures, salts A and salt B would crystallize out. So that leaves us with our answer as crystallization. Question 4. A mixture of calcium chloride and calcium trioxocarbonate 4 in water can be separated by. Now here we have to look at the properties of these salts, the individual properties of these salts, and take advantage of that. This is something you would actually learn from the solubility of the salts of the metals in the periodic table. Now, calcium chloride is an ionic compound. That makes it soluble in water. Now, calcium carbonate has an interesting nature about it. Yes, calcium is a metal. However, the trioxocarbonate 4 salts of the group 2 metals, of which calcium is a group 2 metal, the trioxocarbonate 4 salts of the group 2 metals are usually insoluble in water. So if you have both salts in water, it means calcium chloride will dissolve in the water, calcium carbonate will remain undissolved. So our calcium chloride forms a solution, while our calcium carbonate would settle somewhere or either float. Then, of course, we will now apply the method of filtration. And when we apply the method of filtration, our calcium carbonate will collect as the residue because it is insoluble, while our calcium chloride, being ionic and soluble in water, will collect as the filtrate. And with this, we can clearly say that our correct answer is filtration. Question 5. A mixture of kerosene and diesel oil can be separated by. Now, kerosene is organic, diesel oil is organic. So what this clearly tells us here is that they would dissolve in each other. So they are miscible. That's the word. They are miscible. So of course, we cannot use sublimation. We cannot use precipitation. Also, we cannot use crystallization. So because they are miscible and they're both liquids, we'll take advantage of the difference in their boiling points. Kerosene has a different boiling point from diesel oil. So we're going to heat this mixture so that they will separate out based on the difference in their boiling point. So that leaves us with the answer distillation. Question 6. A mixture of sodium chloride and calcium carbonate is best separated by. Now, sodium chloride is an ionic compound. That makes it soluble in water, which is a property of ionic compounds. You acquire this knowledge from studying chemical bonding. That's ionic compounds and covalent compounds. Calcium carbonate, in its own case, is considered ionic. However, calcium is a group 2 metal. And from our knowledge of the periodic table and the solubility of salts, the trioxocarbonate 4 salts of the group 2 metals are actually insoluble in water. So for this purpose, we are going to use filtration. So we'll have both our sodium chloride and our calcium carbonate in a beaker with water, so that our sodium chloride dissolves in the solution while our calcium carbonate separates out as an insoluble component. Then of course, we can now use our filtration setup. Where our calcium carbonate will collect as the residue, while the sodium chloride will be collected as the filtrate. It will pass through the filter paper as our filtrate. So that leaves us with the answer. Dissolution, that's where we dissolve them in water. Then the sodium chloride dissolves in the water, then followed by filtration, where we filter to obtain the calcium carbonate as the residue and the sodium chloride as filtrate. Question 7. A sample of orange juice is suspected to have been contaminated with yellow dye. Which of the following methods can be used to detect dye? Now, the presence of pigments or colored dyes are usually detected using the method of chromatography. Where the components of these colored mixtures are usually separated based on their difference in solubility in a particular solvent. So we can just have a container with a particular solvent, which could be water, or which could be alcohol, acetone, whichever solvent that is suitable. Now the components of the mixture have different solubilities in that particular solvent. So we introduce our paper chromatogram, so that, and then we have a baseline drawn with pencil just above the level of the solvent. We place a drop of the pigment at this baseline and then allow it to stand. After a while, the different components of the dye or the mixture will separate out based on their solubility in this particular solvent. Those ones that are more soluble are the ones that will separate out last, and the components of the mixture that are the least soluble are the ones that will separate out first. So this leaves us with our chromatography as our answer. Question 8. A solid can be obtained from its saturated solution by... Now, a saturated solution is a solution that would not dissolve any more solute at a particular temperature. So here we're talking about a solid from its own saturated solution. So let's say this is a beaker containing our solid in its own saturated solution. All we need to do is apply some heat. We heat to actually concentrate the solution or make it saturated so that some water actually leaves. And then on cooling, the solubility of the solid begins to decrease. And our solid now begins to form crystals. As the crystals form, we can then pour out some of the solvent and then dry out our crystals, or allow them to dry. So our answer, of course, is crystallization. So crystallization is a separation technique that takes advantage of the fact that on cooling of certain salts in their own saturated solution, they come out as crystals. Their solubility decreases, so they begin to form crystals. And that is what we see in this case. Question 9. A substance is said to be impure if it is colored, no. It has a low melting point, no. It dissolves in water with difficulty, no. Its melting point range is wide. This is our correct answer. Now, usually a pure substance has a sharp or specific melting and boiling point, and we use that to actually check for the purity of substances. You know, when a substance's boiling or melting point deviates over a wide range, then we can tell that it is impure. So the two criteria for purity is a sharp melting and boiling point. Question 10. A substance is said to be pure if the two criteria for purity of a substance is having a sharp boiling point and having a sharp melting point. These are the two criterion used to check for the purity of a substance. Now, looking at our options, the only option that talks about this is option number 4. So that leaves us with option B as our answer. So 4 is the only criterion that can be used to say if a substance is pure. Question 11. An orange drink concentrate is suspected to contain traces of poisonous green dye and a harmless dye having the same boiling point. Now, clearly, seeing the fact that they have the same boiling point means that we can't even use any method that has to do with distillation, because distillation takes advantage of difference in boiling point. So that method is clearly eliminated from our answers. Which of the following technique is most suitable for isolating the dye? We are dealing with dyes or colored pigments. The method that can be effectively used to identify and separate the components of a dye or colored mixtures is paper chromatography, which takes advantage of the differences in their solubility in a particular solvent. So option A is our correct answer. Question 12. Consider the reaction represented by the following equation. Silver nitrate plus sodium chloride will give us silver chloride plus sodium nitrate. The steps that could be taken to obtain pure dry sample of silver chloride from the mixture includes, now let's look at this carefully. Answering this question would require us to take into consideration the physical states of our reactants and products. The silver nitrate is aqueous, sodium chloride is aqueous. This means that they are both dissolved in water. Water is a solvent. Now, after mixing these two salts together, we're able to get a solid product. This solid here tells us that the silver chloride is a precipitate. It's a solid that comes out of the solution. So it means that after this reaction must have taken place, a solid was formed, a solid that was not soluble in the medium. So clearly, to obtain this product, we'll need to filter. So let's say this is our container, and let's pretend that this is our silver chloride, which is a solid. Now, the fact that it precipitates as a solid means that we can just simply filter this using our filtration setup. We can just filter it. So it collects as the residue. Our silver chloride collects as the residue. After it collects as the residue, it may still be contaminated with some of our sodium nitrate. So we will need to actually wash or rinse with distilled water. So this residue will then be rinsed or washed with distilled water. Yes, you have to use distilled water. And after washing or rinsing with distilled water to remove any impurity, it is then allowed to dry. Either you dry it in a desiccator, you can dry it in a desiccator, or you could use a desiccant, that is a substance that can absorb the water from it without reacting with it. That leaves us with option C as our correct answer. Filtering, washing, and drying. Now, we cannot go with option D, filtering and evaporation to dryness. No, evaporation to dryness would really make our product impure. So option C is our correct answer. Question 13. In which of the following are the substances arranged in their correct order of increasing melting point? Now, you have to look at the nature and properties of each of the elements or compounds here. So let's start with option A. Diamond has a high melting and boiling point because, of course, it is very dense and the hardest substance known. Sulfur is a non-metal. Sodium chloride is an ionic compound, so it's going to have a high melting and boiling point. But you see, sulfur is a non-metal, so it has a lower melting point than diamond. So A cannot be the answer. Option B, diamond, because diamond has a higher melting point than sulfur, so that eliminates option B. Now let's look at option C. Sulfur is a non-metal, it has the lowest melting point here, so that also eliminates option C. Now option D, sulfur is the non-metal. Non-metals have low melting and boiling point, followed by sodium chloride, which is an ionic compound. It has high melting and boiling point. Then diamond, even though it's a form of carbon, but diamond is the hardest and densiest substance known. So that confers on it a very high melting and boiling point. So our correct answer is option D. Sulfur is a non-metal, low melting and boiling point. Sodium chloride is an ionic compound which typically possess high melting and boiling point. And like I said, diamond is the hardest and densiest substance known. Question 14. Potassium nitrate, potassium trioxynitrate 5, yeah, you can also call it potassium nitrate, can be obtained from its solution by potassium nitrate can be obtained from its solution. This means that it is dissolved in its own solution, where water is the solvent. So we have water as a solvent, and then we have the potassium nitrate, and we want to obtain it from its own solution. Of course, the clear method here would be crystallization. We heat so as to evaporate some of the water, thereby saturating the solution, then allow it to cool. As it cools, the potassium nitrate, its solubility begins to decrease at lower temperatures. So crystals begin to form. Crystals begin to form. As the crystals form and the solid is formed, we can now clearly obtain the crystals, rinse the crystals, and then dry them. So our answer is crystallization. Question 15. Pure water can be made to boil at a temperature lower than 100 degrees Celsius by... Now, you see, the higher the atmospheric pressure, the greater the thermal energy that is required for water to boil. So the boiling temperature of water depends on the atmospheric pressure. If you reduce the atmospheric pressure, you reduce the boiling point. So for example, if you take water up a mountain where there is less atmospheric pressure, it will boil at a lower temperature. So based on this argument, our answer is decreasing the external pressure would cause water to boil at a lower temperature. Question 16. Separating funnel is used for separating a mixture of... Now, a separating funnel is just simply an arrangement that allows us to separate two immiscible liquids. When I say immiscible liquids, that is liquids that do not mix together. Let's say you have oil and water. So this could be a setup where we then have a tap. So when you have the two immiscible liquids, they will separate out into two distinct layers. You know, the denser layer being at the bottom. So the denser layer at the bottom, while the lighter part at the top, or the less dense part at the top. So that when we open the tap, the denser layer now being heavier and at the bottom will pass through our tap and is collected. This is not really an effective separation technique, because in the process of separating the denser part from the lighter part, some lighter part will as well escape into the collected denser part. So based on this explanation, our answer is option C, liquids that are immiscible. That is, like I said, liquids that do not mix based on the differences in their density, like water and oil, kerosene and water, kerosene and so anything organic or inorganic, organic, inorganic, polar and non-polar. Question 17. Separation of mixture of solids by physical methods can be based on differences in the following, except... So of course, we can use particle size as a difference to separate the components of a mixture. For example, separating minerals like gold another mineral deposits. We use particle size. Melting point, of course, we can use the difference in melting point to separate the components of a mixture. Solubility, we can use the difference in solubility. We talked about like chromatography. Molar mass. Molar mass. Molar mass is simply the amount of 1 mole of, is the mass of 1 mole of a substance. Is the mass of 1 mole of a substance. So this is just a measurement. Mass of 1 mole of a substance. For example, the molar mass of ammonia just simply tells us that in 1 mole of ammonia, we have 17 grams. So this is not used as a basis for separating the components of a mixture. So that gives us option C as our answer. Question 18. The components of a universal indicator solution can best be separated: A. Chromatography, B. Crystallization, C. Filtration, D. Evaporation. Now, universal indicator is a mixture of pigments. It's a mixture of pigments, and pigments are best separated by the use of chromatography. So that leaves us with option A as our answer. Question 19. The most suitable method to use when separating an insoluble solid from a liquid, an insoluble solid from a liquid, an insoluble solid from a liquid. So let's pretend that this is the liquid, then the insoluble solid could either be at the bottom or floating on the surface. The basic idea here is that this solid is not soluble in the liquid. So we have it in this. So the simplest way to separate this is to use filtration. Where we use our filtration apparatus, the insoluble solid collects as the residue, and then our liquid passes through as the filtrate. So that leaves us with filtration as our answer. Question 20. The most suitable process of obtaining water from an aqueous solution of sugar. Now, obtaining water from an aqueous solution of sugar. So we're looking at a solution in which water is the solvent and sugar is the solute. And in this case, we are not interested in collecting the sugar. We're interested in collecting or obtaining the water. We're interested in collecting or obtaining the water. So we're going to have our solution here because the sugar, of course, will be dissolved in the water. So this is our solution of water and, of course, sugar. So all we need to do is apply heat. Apply heat, and then the water would boil out as vapor. The vapor goes through a Lebesgue condenser. So this is a Lebesgue condenser, when the water boils, because there's a cork here to prevent the vapor from escaping, as the water boils, it passes through the delivery tube into the library condenser, where of course cold water goes in here, and then hot water comes out. As the cold water goes in, it absorbs heat from the vapor so that the vapor now becomes water, and liquid water is collected in this particular beaker. Now, this method I just described here is simple distillation. This is the method of simple distillation. What makes this method unique compared to typical evaporation is that it allows you to obtain the solvent. Evaporation sacrifices the solvent. And this question is asking us of a suitable method we can use to actually obtain the solvent. So this is the only method that can enable us to obtain the solvent, which in this case is water. So our answer is distillation or simple distillation. Question 21. The purity of a solid sample can best be determined by its... Now, the purity of substances are determined using boiling point, and melting point. The purity of samples are determined using boiling point and melting point. We can as well call them the criteria for purity. You need to have a sharp melting point, you need to have a sharp boiling point. However, this question is talking about the purity of a solid sample. A solid sample. Clear, you see we have melting point and we have boiling point in our options. So which do we go with? Now, because we're dealing with a solid, we are going to go with the melting point. So melting point is the answer. If it was a liquid sample, then we'd go with boiling point. But since it's a solid, melting point is our answer. Question 22. The separation of a mixture of calcium trioxocarbonate 4 and sodium trioxocarbonate 4 is most easily carried out by using the differences in their... Now, both of them are carbonates of metals. But what distinguishes them here is that calcium is a group 2 metal, sodium is a group 1 metal. Now, under the properties of the solubility of metallic carbonates, we would observe that the trioxocarbonate 4 salts of the group 2 metals are insoluble in water. The trioxocarbonate 4 salts of the group 2 metals are insoluble in water, while the trioxocarbonate 4 salts of the group 1 metals are soluble in water. So on this basis, If we put both salts in water, calcium carbonate will not dissolve, sodium carbonate will dissolve, and then after this now we can move on to carry out filtration. It means that the physical property we can use here is option D, solubility. Solubility. Question 23. The separation of oxygen from nitrogen by fractional distillation of air is possible because, now the point of interest here is the term fractional distillation. Now this is a separation technique that takes advantage of the difference in the solubility, the difference in the boiling point of the components of a mixture. It takes advantage of the differences in the boiling points of the components of a mixture. Now, air is a mixture of gases. To separate the components of air, we first of all pressurize the air so that it becomes liquid. Liquefied air is then subjected to fractional distillation. Now, we're separating oxygen from nitrogen. Oxygen boils at minus 183 degrees Celsius. Nitrogen boils at minus 196 degrees Celsius. So clearly nitrogen has the lower boiling point of the two. So when we now subject this to fractional distillation, nitrogen will boil or separate out first before oxygen. So that means our answer is the difference in their boiling points, option A. That is what fractional distillation takes advantage of. Question 24. The separation technique that is suitable for separating iodine from tetrachloromethane. Okay, iodine from tetrachloromethane. Now, tetrachloromethane is an organic solvent. Iodine, so this is organic, this is inorganic. So we cannot take advantage of difference in their melting point. Filtration, not really. Filtration would not give us a pure sample. Now, this technique is not really common at the O-level chemistry, but the appropriate technique here is what we call the solvent extraction. Now, tetrachloromethane is the solvent. We will use a certain agent. In most cases, we use alkaline agents to extract the solvent. This method would effectively extract the entire solvent, leaving behind the iodine. Now, this iodine may still have some impurities, so we may expose it to heat so that it undergoes what we call sublimation condensation. So this is our mixture. So we can add a solvent extractor like an alkaline agent that would extract the tetrachloromethane. Then we're now left with our iodine. But because our iodine still have some contaminants of the tetrachloromethane, we'll then apply some heat. And then place an inverted funnel. So as we apply the heat, iodine is known to sublime. You know, it will turn from solid to gas, and then it will settle. That's the condensation now. It will settle at the bottom, on the walls of the inverted funnel, and then collect there as solid, pure iodine crystals. So this method I just explained is called the method of solvent extraction. I said this is not really popular at the O levels. They don't teach this at the O levels. Question 25. When naphthalene on heating changes from the solid state directly to the gaseous state, it undergoes, of course, when matter changes from the solid directly to the gaseous state, that process is called sublimation. That process is called sublimation. Question 26. Which method of separation does the following diagram illustrate? Now, this is an evaporating dish, and this is a solid. This is a solid mixture or compound. Now, this is an inverted funnel, and from what we can see here is something covering the inverted funnel so that when this solid is heated, it sublimes, it changes from solid to gas. And as the gas makes contact with the lid or the sides of the inverted funnel, it condenses into solid. So this method is the method of sublimation. Question 27. Which of the following method is not used for the separation of mixtures? Chromatography is used for the separation of mixtures. Crystallization is used for the separation of mixtures. Distillation is used for the separation of mixtures. Electrolysis is used for the separation of the components of compounds or the preparation of compounds. For example, the electrolysis of water. The electrolysis of water is used to separate the components of water, hydrogen and oxygen, using the Hofmann voltammeter. So options A, B, and C are methods used for the separation of mixtures, but option D is a chemical process used to separate the components of some compounds or to even prepare some compounds. So option D is our answer. Question 28. Which of the following methods can be used to separate a mixture of two miscible liquids with different boiling points? Now, first of all, the two liquids are miscible. There are two liquids that are miscible. That means they're mixed together. And then they have different boiling points. Now, decantation is simply a technique where we can use to separate an insoluble solid from a liquid. You just pour out the liquid and you get that. For filtration, again, this method is used to separate a mixture in which one of the components is insoluble in the solvent. Evaporation, they are both miscible, however, one of them vaporizes at a certain temperature. Now, the only method here that is suitable for separating a mixture of two miscible liquids with different boiling point is distillation. Distillation, where it takes advantage of the difference in their boiling points. The component with the lower boiling point separates out first. It separates out first. Like we see something like this. Let's say we have two components, two liquids now, A and B, both miscible. Now let's say A boils at 78 degrees Celsius, B boils at 80 degree Celsius. I will need a thermometer, so I will able to take the temperature. Need a thermometer, and of course we have our delivery tube connected to our Liebig condenser. And then our collecting container, whatever it is. So these are Liebig condenser. Cold water in, and then hot water out. So you see, by the time we begin to heat, once the temperature gets to 78 degrees Celsius, then we know that component A is boiling out, and it's collected here. And then once the temperature now hits 79 degrees Celsius, we know there is no more component A. If component A boils at 78, then once it hits 80, we now know that it's time to collect component B. So this is a simple distillation apparatus. Question 29. Which of the following methods can be used to separate blood cells from plasma? The method that can be used to separate blood cells from plasma here is centrifugation. Now, this takes advantage of the difference in the density of the components of the mixture. Now, if you look at blood, okay, the blood cells, the blood is put inside simple tubes called the centrifuge tubes. We call them the centrifuge tubes. And then these tubes are placed in what is called a centrifuge machine. You know, you have the machine where these tubes fit in. And then the centrifuge tubes are rotated at a certain speed. Now, in the course of the rotation, the most dense components, like in the case of blood now, the blood cells are more dense. They will collect at the bottom of the centrifuge tube, while the plasma, which is fluid or liquid, collects at the top and just simply decant everything over. So our answer is centrifugation. This method is usually used in hospitals, not just for blood samples, but also for urine samples, even for fecal matter analysis of stools, where parasite eggs, some parasite eggs will settle at the bottom, depending on the parasite or the eggs of worms you want to investigate. So apart from separating blood cells from plasma, this method is used to separate the components of urine. Maybe if there are so much sugars or salts in the urine, the salts will settle at the bottom. Also to separate the eggs or the segments of parasites from human feces. Question 30. Which of the following procedure is suitable for identifying the food coloring added to a pastry sample? Food coloring, pigment, color dyes. It's chromatography. So our correct answer here is to do a chromatogram of the coloring extract. So option B is our answer. Question 31. Which of the following separation techniques Which of the following separation techniques would show that black ink is a mixture of chemical compounds? Black ink, colored mixture, pigments. Our answer is chromatography, used for separating colored pigments, colored mixtures, and the rest of them. Question 32. Which of the following solid is or are expected to have a relatively high melting point on the basis of the structure? Calcium oxide, sodium chloride, sulfur, iodine. Okay, now calcium oxide is an ionic compound. In chemical bonding, we know that the bond between a metal, calcium, and a non-metal, oxygen, forms an ionic compound, and they have high melting and boiling points. Organic compounds have high melting points and boiling points. Sodium chloride, this is another ionic compound. Metal, non-metal, so another ionic compound. So this should also have high melting point and boiling point. Sulfur is a non-metal. It's a non-metal. So sulfur, in terms of structure, it's covalent. It's covalent. And covalent molecules usually have low melting and boiling points. Iodine is also a non-metal, covalent as well. You see, iodine molecules, sulfur molecules. Molecules have low melting points and boiling points. So based on this information here, based on our knowledge of bonding, which ones will have a high melting point on the base of structure? That leaves us with 1 and 2. That means our correct answer is option D, 1 and 2. That is calcium oxide and sodium chloride. Question 33. Which of the following substances, lettered P to V in the equation below, will be left on the filter paper if the reaction mixture were filtered? Now, P is aqueous. That means it's packed with the solution. This will pass through a filter paper. Q is aqueous. It's one with the solution. It will pass through the filter paper. Now, V is a solid. That means it is insoluble. It is insoluble. It cannot pass through the filter paper. It will collect on the filter paper. So V will collect on the filter paper as our residue. R is aqueous. It will pass through the filter paper because it's one with the solution. T is a gas. This will of course escape. It will escape as a gas, becomes one with the air in that environment. So our answer is clearly V. Copper 2 tetraoxosulfate 6. This shouldn't be here. So it's copper 2 tetraoxosulfate 6, or copper 2 sulfate, can be obtained from an aqueous solution of copper 2 tetraoxosulfate 6. So the aqueous solution is the copper 2 sulfate pentahydrate. So of course, so you have a container of copper 2 tetraoxosulfate 6 pentahydrate, and we want to obtain only the copper. That means we need to get rid of the water. We need to get rid of the water. Now, evaporation to dryness is not the suitable technique here because copper 2 sulfate actually forms crystals. So we're going to use method of crystallization. We're going to apply some heat here. And when we apply some heat, some of the water will leave. Some of the water will leave, thereby saturating or concentrating the solution. Then when we allow the saturated solution to cool down, copper 2 sulfate crystals will begin to form. When the crystals eventually form, we can now carry out filtration, obtain the crystals, rinse them, and then dry them in a desiccator. So our answer is crystallization.